Yeah, for this is a statically typed language. Otherwise, you're looking at a dot, which every function is going to start because it's dynamic.
Okay.
No, that one's not. Yeah. Okay. I want to talk about declarative. This is a tricky one. I was an electronic engineer, so I'll use my background. You are as well? Okay, so it feels like you are the only one who can understand this, or maybe everyone can because we go through the 12 years of studies. This was a very simple interview question I encountered about 10, 11 years ago. It was just a very simple RC circuit. Is it how you write it? I forgot, like, yeah. Okay. Okay. Yeah. The question was to draw a graph of the voltage on the resistor. I think. Remember, it's a bit vague. Can you give me the answer for the graph?
No.
No? Okay. So I can just make things up here. Okay. So what I did, what I remember is what I did was immediately I assigned the capacity of this, let's say the resistor would be a R, and then I do the math, right? And to determine, and to plot the chart, basically, if I'm a computer, I have that formula, I can plot the chart. So I was immediately stopped by the interviewer. Why? Because he wants me to give him an answer straight away. Because resistor has a capacitor has a way of reserve charging kind of a thing going on with it. So that means, and a resistor, if there's no capacitor here, you were looking at a line here, right? And plus that, you were just, like this. Yeah, simple. You don't need to write anything. Maybe we remember this by the education, right? So we remember this kind of graph like this, but this is a way to look at a mathematical problem in a very different light. It is a kind of a declarative kind of way to say, I don't need the precise numbers in order to tell you how the system behaves. How the system behaves is the collective behavior of individual parts. And it's easy demonstration to say, it stops here because the resistor and because the charging goes up like that. In functional programming, it's very similar. Let me give you another example. Factorial. So if let's say we want a function that takes n, I'm going to write it in JavaScript, and give me this n times to 1. Yeah. Do you know how to do this? Anyone? It's a reducer. How do I reduce it? I get a number, and then let's say it's a 5, then 5, 4, 3, 2, 1. Yeah. Recursive? Yeah. Okay. All right. So recursive. How do we do this? How do we recursive? Let's just do this thing.
Just do a while loop.
What?
Where you do a while loop.
till n becomes 0. Oh, sorry, and n bigger than greater than 0, and then you do n times n minus 1, which is you define the result equals n minus 1, and then you do n minus 1, I guess. I have no idea.
Is like
Yeah.
so larger than 0.
0, yeah, bigger than 0.
Or
if it's not bigger than 0, then you at that time you return the result or something. I have no idea.
okay.
Yeah.
So this is a keep timing. So
Yeah.
what do we do here again?
But if you define a function which is have the f, you need to possibly create a function the first time.
Right. So is it like an embedded function here?
Yeah, probably.
Right. Okay. Let's just get rid of it.
I would think about a reducer maybe would be better. Is it a reducer?
This is.
Oh, sorry. This is not array. Sorry. Sorry.
Yeah. Okay. So let me use Haskell a little bit. In Haskell, you just write this. It's a lazy language, so you can have infinite things going. The product is just ton whatever's in there. So given the n,
Okay.
then just stop to whatever place. So it's very readable, right? So you take the first n element of the product of an array. Whenever it is, the n will be whatever stopped here. It's a lazy language because the evaluation of this thing will not happen until here. Yeah. So it's just a demonstration to say we don't construct our program to show how to do the calculation. We writing the definition of things down instead. And the language is a higher level enough, it will do the thing for us. That is functional programming in a different light, I guess, because you can write it in recursive or like you can even write it using like 200 lines or something, but still being functional. But that's the declarative side of it. Alright. Okay. So that's that for composition and a bit of a reasoning. And now I'm going to talk about the thing in the middle, types, as a kind of abstract. For a book, you get a read abstract, right? So this types thing is to say what we're going to talk about in the next, how many weeks, and then here is a sneak peek into that. The problem with JavaScript, not really a problem, is it is a dynamically typed language, which brings a lot of problem if you not handle it properly. Sometimes you get a string when you expect integer, and you plus another integer, it becomes, we all have this kind of problem before. Then you need to keep that knowledge in your head, right? To actually, when you construct your program, you need to be careful. Here is a trap here, there's a trap there, to avoid them. my approach, it's only my approach, is to forget the types are dynamic. They are all static. Just treat it like that. And you need to convert them if you want another type. Simple as that. So the focus has been shifted to understand a static typed language instead of keeping in mind that you have all those things you need to worry about when dealing with JavaScript. Now, when dealing with types, there is this thing. I'll throw out very like many jargons of functional programming. I'll explain them. ADT. So algebra data type. Okay. What does it mean? Any type actually into three kind of categories. One is in JavaScript we call primitives. Right? Can we name them?
String, number,
String,
boolean, null, undefined, and
Boolean.
boolean. I already said that. String, number, boolean.
Undefined.
Pretty much it.
Yeah, symbol.
Not a number.
Single, yes. Yeah.
Not a number is actually a number type.
No, but,
Number type, yeah, okay.
The object. Alright. Object. Object is
Mm.
Not primitive type. Probably. Object is probably not a primitive type.
No.
No, it's not. No, it's not.
Okay.
It's not primitive.
Yeah.
Why it's primitive is it contains all the information. If you compare them to, let's say, array, it's such very useful construct, right? You can use array for every single example in function programming, basically. Array. You say array, that's not enough because you don't know what's inside. You need to say array of something in order to complete the sentence, right? Then you know the type. So those are primitive types. So that's one type of let's use P. Or what else we have? We have product type. What is a product type? So this type contains both types of two types. So that will be. Do we have an example of that?
Number Boolean 0, 1.
That is this type. We're talking about type level, right? You're talking about, let's say, 0, 1 is the member of Boolean integer, right?
Yeah.
We're talking about a type contains another two types. Can you construct something like that in JavaScript?
Yeah.
Yeah.
Objects, yes. So it's very easy, right? You have, something, right? Yeah. So those two values are tagged by 1 and 2. Remember, tagged is a construct we use a lot. Well, it's a name we use a lot in function programming. So they're tagged by those two things. And this is a string, this is a boolean. So essentially, this is a product type between boolean and string. Yeah, okay. And so this product type. Well, we have product type, we have the other side as well. We have co-product, or I'll just write both co-product or sum type. You will hear people use them interchangeably. Because, co is the reverse of things, just English language. And sum is just that. It's like algebra. It's like algebra, right? 1 times 2, 1 plus 2. Same thing. In types, you have the same thing as well. So, can you give me an example? This one's a bit hard, I think. So, instead of looking at a type containing two types, you would have a type contains either one of the types you want to express.
Oh, like the uni type in the TypeScript. So uni type in the TypeScript. So
How do you write uni in
uni type,
TypeScript?
uni type in TypeScript.
Yeah.
There's a uni type in TypeScript. So you can define, let's say for example, you're getting that object, right? So
Yeah.
you can do double quotes 1, and then you can define that it's either a string type or it's a number type.
Oh, so it's like a
string. Yeah, and then
or
dash, and then number.
Yeah.
So then you define that this one is a uni type, which means it can be a string or it can be a number.
Oh, okay.
In TypeScript.
Right. Yeah. So
Is that the one you're talking about?
yeah, possibly not one here for our purpose. You would have something here.
Okay.
You have, like, let's say a variable.
Yeah, sure. Of course. Yeah.
To express this thing can be one thing or another. You write in TypeScript, we have these things. That means, don't get confused that with dynamic typing. This is not dynamic typing. There's no conversion. You put a boolean here, it doesn't work. Right? Okay. So you express the sum of two types, either or. It's like in logic, right? The sum in logic is the or. The product in logic is the and. Logic and, yeah. So that's another important thing about category theory, which is the foundation of functional programming, is that I just said, like, the product concept exists in formal logic, like the word of the length, right? And it also exists in types, in functional programming. And probably exists, or it definitely exists in group theory or set theory. Because in set theory, a product is, you have a bunch of numbers in the set. A product is just the combination of things. Right? Yeah. So that's a theory, like, it's abstract enough to express other theories. But when you think about those three things, you actually can express anything using those three constructs, right? Primitive, product, and sum. That's even a concept